So to start the day, we have a workshop from IBM. So excited to introduce Danish and Karan, who will be telling you about the research IBM is doing, applying artificial intelligence to education. Danish is an NLP expert who will be telling you about his research at IBM, also his PhD on question answering. And Karan will be walking you through the Watson APIs. So who's received credits for IBM Bluemix? Raise your hands. Almost all of you? Have you been able to activate the registration codes? Yeah? Okay, if you're having any problems with that, come and see us afterwards. But Karan will be taking you through how to use the Watson APIs on Bluemix. And also, IBM have put together some very special challenge problems specifically for all of you for this hackathon. And this will be a great opportunity for you to work on one of these if you're struggling for ideas. So we encourage you to participate, ask lots of questions, and we hope this is really useful for you. So handing over to Danish.
Thank you. So can you all hear me with this mic? Yeah. Okay. So morning, everyone. I'm Danish. I work at the IBM lab here in New Delhi. So my background is in machine learning, natural language processing, and what I'm going to do over the next 45 minutes before Karan will walk you through the Bluemix APIs is tell you some of the work that we've been looking at IBM Research in the space of AI for education, and then maybe motivate some problems that potentially you could look at. Those are open problems that even I and my team are currently looking at, and maybe you could come up with ideas that could help solve some of those problems. So just by a show of hands, how many of you have had any experience of working in machine learning or natural language processing before? Maybe machine learning first, just pure machine learning, how many of you? Okay, that's a sizable number. And NLP background, any of you? Okay, great. Have any of you used the Watson APIs before? Good, so this session will be useful. Okay, so, and I want to keep this talk interactive because this is more of a hackathon talk. I'm not really trying to present research or have a one-side conversation. So just make sure if you have any questions, raise your hands and I'll stop and take those questions, okay? So, so today we're in this era of big data, right? All our devices are connected. There's a lot of resources that are getting digitized all the time. And to put that in perspective about how much data we generate about 2.5 quintillion bytes of data every day. That's I think quintillion is 10 to the power 18. So 10 to the power 18 bytes of data is an enormous amount of data. And 90% of that data was actually generated in the last 2 years. And these numbers are actually even not very recent from 2017. These are from about 2 years ago. So I imagine we generate a lot more today. And a lot of this data has enabled us to do things that we were previously not able to do, right? We've got cars that are collecting data all the time about how the engines are working. We've got data that's being collected on our consumption patterns, our online transactions. And we have, with the digitization of education resources, we are now starting to collect and have access to a lot of data pertaining to education, right? And this is very important, right? Because education today is at a tipping point, right? We have significantly more demand than supply. We will, so for example, in India, we will have about, I think, 45 million more 10th class students by 2020. And in order to be able to put them through college, we would require nearly 50,000 colleges, right? And we are nowhere close to that number today. Even students who do make it through college today, employers find them to be unemployable, right? And the numbers are staggering, right? 47% of Indian graduates are unsuitable for any job according to some employment surveys. And that's just not an India problem. That's an EU, that's a worldwide problem. For example, in the EU, those numbers are around 27%. So you have to ask yourself today, right? Why do we see this happening? Why do we have graduates or students who have even gone through the cycle of learning not be employable today, right? And a lot of that could be, it could be a variety of reasons, right? You don't have the same amount of quality. Students could be studying outdated material. They may not have inspiring or engaging teachers. And even in the US, for example, about 8,300 students drop out of high school every day, and that's a huge number. That adds up to about $320 billion of lost earning potential. Right? And of course, there's also this element of costs, right? Setting up schools is expensive, tuition fees are expensive. One of the statistics that I find staggering is that the US students in the US are actually in approximately $1 trillion of debt, right? If you think about that number, that's more than the GDP of most of the economies of the world. Um, so today with digitization and content platforms, right, we have this opportunity to change some of that. And I think this hackathon is a good place to come up with ideas, brainstorm on some of the solutions. We may not be able to solve everything. We may be able to solve a small part of it. But I think it's important as technologists, as people with interest in this area, to do something that could help, solve this or alleviate some of the problems that we see. Um, so, um, so let's look at what's been happening most recently, right? So given that we've got digitized resources, we've got uh, uh, a lot of, so the internet penetration has gone up, cost of technology has gone down, you've got digitized resources. So what has that enabled for us? We've all used e-learning courses at some point in time, right? So how many of you, by show of hands, have used some sort of e-learning course or have learned something from a video lecture? How many of you found that to be personalized or good for your specific needs directly? Right? So very few. So that's one of the challenges, right? So it's one thing to be able to put resources out there. It's another to be able to make sure that they're tailor-made and adaptable to your specific needs. And that's the shift that we are gradually seeing, right? So we're moving to an analytics-driven, personalized experience of learning. Um, and that is getting enabled primarily by big data. How is that getting enabled by big data? For example, we can model how students have been learning or utilizing content. Students with similar backgrounds or similar characteristics, which are machine driven or machine learned, can be used to infer patterns and suggest what other kinds of content that you may find relevant. So you see YouTube doing that all the time. You see Facebook ads and Amazon ads doing all of that. You buy a book and you start seeing other books which are not bad. You often find them to be very useful. And you do the same thing with education data as well. So when you take a course, you could recommend additional courses, you can recommend additional video lectures, but you want to make that even more personal, right? You want to have that experience to feel like a real learning experience. I don't think any of us would not prefer a person walking us through a course than still watching a video, right? So how do we get to that, right? So one of the ways to do that is to enable maybe like a conversation-based tutor, but then that has its own challenges. How do you, for example, the conversation engine needs to be smarter than you in terms of the background that it is teaching you. It should have adequate knowledge. It should be able to infer what you know, what you don't know. It should be able to sustain a conversation. It should be able to answer your queries. And that's what we'd like to move towards, right? So in this talk, what I'll do is I will talk about some of the examples of things that we've looked at IBM. So the first two, for example, the first one is about predicting students at risk. So given longitudinal data of students' attendance history, their demographic profiles, can you say something about who might need help somewhere in the future, right? And to be able to give that timely help is very important because you could help address one of the problems we talked about earlier, which was maybe reduce the dropout rate and control disengagement. The other one that I'll talk about is on analyzing learning material as well, right? And I think this should be of interest to those of you who've had some background in NLP. And, uh, and I'll motivate why that is important and how that relates to personalized education when I talk about that. And these two, in fact, are available as an IBM Watson solution for educators. It's called IBM Watson and Lite. And it is in fact being used by some of the school districts in the US, and we're trying to get that to work with some higher end institutions as well. Then I will talk about a use case around early childhood learning, which also has elements of AR in it, augmented reality in it. And then maybe just briefly talk about the cognitive career counselor, which is one of the most recent things that we've been looking at. Finally, so personalized tutoring system is what, maybe the best or the epitome of what a learning experience should be like. I will talk about some of the open challenges there. What are we looking at? How do they relate to existing NLP sub-problems that you may have had worked on or have studied about earlier? So let's just get started. So I like this picture because I think it paints a good classification of the different kinds of problems that you might want to tackle, right? So if you think about so if you want to think about helping teachers, right? What could help teachers? Teachers have nearly 50 to 60 students per class. You have all sorts of students with all sorts of backgrounds, each with their own learning abilities, each with their own skills and weaknesses. And to be able, for a teacher to be able to understand who he or she needs to be giving more attention to, who needs more help, who's probably better off on their own is hard, right? It's hard work. They need to look at their assessments, they need to look at their attendance profile, they need to be looking at how they've been doing on their homework. So just enabling teachers to be able to have a one view of a one view dashboard of what that looks like is actually very helpful. Um, and maybe if we have some time, maybe I'll show you a quick video of how that's actually been used by some of the teachers. Some of the work that we've done has been used by teachers and how they found it helpful. But teachers spend hours trying to, tailor their content to the needs of the classroom and the curriculum. But then you want to think about, dashboarding is fine, reporting is fine, but can you do something more, right? You want to take the burden, you don't just want to take the cognitive burden off a teacher. You want to assist a teacher, help a teacher do better at the job, right? Make them more effective as teachers, simply because problems of scale are hard to deal with for anybody, right? So can you look at the data from the classroom and suggest and figure out, okay, this student is likely not to do well on the final year exam or the final exam or some exam, and take corrective or intervening measures that address that. So to be able to analyze all of that, predict students' risk is a very helpful tool for a teacher. Right? So you could think of that as the next step. And you could then think about, okay, so that's good. Now my teachers know that student X is not likely to do well, but now you need to do something about it. You need to have some intervention for it. One of the ways would be that you would talk to the student, figure out where your weaknesses are, why are you not doing well, and all of that. That's good. But how can you assist the teacher do that even better or faster? Right? One of the things that you might want to do is, so let's say I've given an exam, I'm not doing well. Maybe it's because of lack of resources. Maybe it's because I don't understand the content that was provided to me. Now, so far in what we've discussed, it will be up to the teacher to suggest what the student should study or look at. But can you, why can't we analyze the learning material or the content and say, okay, this is what the concepts, these are the concepts that are being covered in this, in the course material that was referred to. Here's what you did with it. Here's probably why it did not work. Here's the additional content that we might want to recommend to the student. And the teacher can then just review that and recommend that. This is also something that we've enabled as part of the Enlight application. And I'll talk about how we enable that from an algorithmic point of view, just so that you get a sense of how much is possible and how. Finally, moving this towards a full-scale learning experience, which is personally interactive, conversation-driven, and can understand the emotive state of a student. For example, you don't want to be frustrating the students with responses or giving them hints and feedback they don't really need. Right? And finally, the last two are about, hopefully, once you have tackled students, you've tackled education problems for K to 12 college students, you want to be able to prepare them for a good career ahead, right? So how do you assess what skills somebody has? How do you assess what skills are going to be good for the student given their learning? How do you map that to skills the companies or institutions would need from an employability point of view? Is also related an interesting problem. So let's talk about the student. So let's talk about what we did with a school, with some school districts in the U.S. So Gwinnett County is a district in Georgia State, the U.S. It's on the eastern side, and it's one of the largest school districts. Okay, it has got something like 178,000 students with nearly 139 schools under them, and we worked with them on a couple of use cases. The first one was trying to predict the academic performance of students so as to be able to give remedial or intervening preventive action, so that you could take preventive action and so that the students could do better on the tests in the future. The other bit was teachers. So Gwinnett County uses like a learning management system at the back, and they have a lot of content that's available. The teachers are creating new lecture notes and putting them online. Students are adding their own content, and there's a lot more related or relevant content that's getting added, right? But typically in the beginning of a class, if you've decided that this is the course material I'm going to take, it's hard for you to then relate new material that's coming in to say what is the learning objective or what is the course objective that this is actually covering. So that was the second problem that we looked at, which was on learning content analysis. And the third one was actually on enabling learning pathways, right? So let's say you've identified students at risk. Let's say you've analyzed content and figured out, this is the course curriculum that it relates to. This is what this particular concept teaches. So you should be able to put the two together and make a personalized, adaptive pathway for me to learn. So the first of these use cases, student risk prediction, right? So we got data from the schools for classes 1 to 8 in subjects of math and science. We looked at, so this data set had data about student enrollment history, the demographic details, disabilities, test performance, what were the courses that they had taken over the years, any disciplinary or absentee issues. So that was student data. We also had data about teachers because that's also a very important factor in how learning progresses in a classroom. So what courses have teachers taken? What students have they worked with? Have they taught? And we also had details of assessments. So we had two assessments that are commonly used there, the CRCT and the ITPS. And we looked at, so those were the tests that we were trying to predict the performance on. And our goal was to just say that student X is at risk or not at risk. And it's amazing how even simple machine learning models can do a pretty good job at this, right? So this is actually using, I think, these charts of, I think, logistic regression on all of that data. It's a simple algorithm. You've all studied that in, machine learning 101, but it can do fascinating things for people who need them, right? So if you look at this chart, so by grade 4, for example, we were able to predict the risk of a student not doing well in his grade 8 exams with very high accuracy, right? And that's useful and that's remarkable. And one of the insights that we got was while immediate data is helpful, the overall enrollment history and the overall data actually helps a lot more. So you can read more about this in a paper that we've written, which explains to you more of the details. If any of you are interested in figuring out how this really worked or what it really looked at, you can look at a paper from I think 2 years ago or 3 years ago that describes this separate issue. So I'll just move on to the next topic. So linking content to curriculum standards, right? So this was an important and difficult problem. So think of it like this. So what is a curriculum standard, right? We've all studied here, so we know what CBSE is, we know what ICSE is, right? So what does that tell you? The CBSE guidelines tell you in class 12, in the course, in this particular subject, you should do this particular course or topic, and within each topic you'll have some instruction, right? Those are basically what the teachers are given as a teaching guideline or an outline to say that by the end of this, your class should be able to do X, Y, Z. And these are pretty granular, right? I mean, they vary from the learning standards to learning standards, but they're pretty granular most of the time. So as an example, you can see how granular they are, right? The student should be able to calculate average acceleration over a time interval using a velocity time graph, right? Other examples were things like, the student should be able to explain the relationship between pressure, volume, and gas. So, and if you remember anything from your high school science, right, you understand that some of it is related to Newton's law. The example on pressure, volume, and gas is related to Charles' law, Boyle's law, and all those kinds of things. And the instruction doesn't really specify that. Now, when you get a book, right, a book is not going to say this topic is going to explain to you the relationship between pressure, volume, and gas. I mean, it could, but that's not something you will rely on. It'll probably talk about a whole bunch of other things and slowly start motivating you into leading to study about Charles' law, Boyle's law, and laws of motion in case of physics. So associating a course objective with a piece of learning material that is describing concepts is not a trivial task of just doing string matching, right? It's also not a trivial task of assuming that those things will be available because you have a lot of courses that are created. They may not specifically be designed for that curriculum, so they may not specify it. They may specify it in different ways. So tackling this is a huge problem, and it's important because if I need to say that, well, Danish doesn't understand the relationship between pressure, volume, and gas, it's of no use to me if I'm just given the book the whole book again for me to study, right? Because I already knew I had that chemistry textbook. I need to be studying the part that's most relevant to me, and which is why it is important to be able to identify what does a book or what does a learning document cover from a course objective point of view, right? Because that's important for an automated system to give recommendations and give you a personalized content recommendation for what you should be looking at. So let's talk about this a little bit more. So here's the high level approach, and I'll spend some time on this. So think of, so what do we have? So we have the syllabus outliners. We have CBSE, ICSE outlines or course curriculum outlines. So we know that it will tell you that in grade 8, there are X subjects. Within each subject, these are the topics. Within each topic, these are the course objectives that you need to cover. Now, that's good. So now, so what do we do, right? The first thing that we start looking at is the instructions, right? The course instructions. So we start figuring out, well, not all terms are important. There are some terms that are important. So what terms could be important, right? You would think concepts, maybe noun phrases could be important because they could be referring to entities or concepts from that domain. So that's one way of extracting them. So we used a couple of different things. One of the ways was in fact using part of speech patterns. So you take a sentence, take a part of speech tagger, write some rules that just see what are the kind of part of speech patterns that occur very frequently in the text for from a concept point of view and get those out. Right? They'll typically be noun phrases of some kind. So you can get those out. The other thing you might want to think about is, okay, what else? So I mean, there's a lot more data in the world, so what else can I use? So you have Wikipedia. We've all used Wikipedia. Wikipedia is a good source. How could you use Wikipedia for this? So maybe if there is a concept that's got a Wikipedia page, it means it's something important. Maybe I should extract that. Right? So maybe you could go find Wikipedia pages that are mentioned within that instruction. But it's not a trivial thing of just finding any Wikipedia page. So for example, if I were to look at nuclear fission and fusion, right, that could mean a whole bunch of things, right? If I have fusion, there's a Wikipedia page on maybe fusion cuisine or something, right? Or if I have the word uniform motion in it, how do you know I'm not talking about like the piece of clothing uniform, right? And how do I know that uniform motion are the things that I need to look at? So it's important to not just assume that you can do a control F and find the Wikipedia page. You need to do so much more. So what do you need to do? Right? You need to be able to analyze the sequence, the sentence, and try to do some sort of disambiguation just based on the cues that are already presented to you, on the data that's already presented to you. So one of the ways you could figure out that uniform motion is more important than the word uniform for me is because if you look at Wikipedia categories of the page uniform, they'll probably go tagging up into something about clothing and fashion or something like that, right? But the page on uniform motion will probably be tied to something around physics or something related. Now remember, you were looking for a particular subject and instruction. So you can rely on the Wikipedia category graph to say, okay, well, this is junk. This is the one that I'm interested in. You can use that as a feature for disambiguating. So when you do let's say you write a sequence tagger to figure out what are likely tokens in my string that are likely to be important concepts, you can use that as an additional feature, right? So that's one way. And we actually do use that, and that's the second bit. So once we extract nuclear fission fusion, now what we want to do is we want to get more information about this instruction, right? It's not very clear. So if I had pressure, volume, and gas, those are the three terms I would get, right? Relationship between pressure, volume, and gas. It means nothing right now, right? There could be many things. So I need to know that pressure, volume, and gas is talking about Charles' law, Boyle's law, or something like that, right? Like, how do I even do that? I can't do that. Right? That's the only information I've been presented so far is my course curriculum. So again, why don't we look for external sources? There are many external sources that we could use. So I'll just talk about maybe two, right? So, okay, so let's assume you have a whole bunch of learning material available with you, right? Untagged, so that's easy to get. You can get articles online, you can get ebooks online, you're allowed to use them. So let's say you have all of that. Now you want to use that to figure out related words to this, right? That makes sense because you could have at a high level picked grade 12 textbooks, grade 8 to 12 textbooks on science, and now you want to study those books to extract concepts out of it, right? and you want to relate them to the concept that you've extracted. So that's what we refer to the learning content-based expansion. So we take a whole bunch of learning content, index that in something like an Apache Lucene index or something, that anything that will allow you to do a quick IR task on it, fetch the top K documents, fairly decent, it's pretty precise because it's concept-driven, entity-driven, it's fairly okay. And you would then want to use that content to do something with it, right? What would you want to do? You want to expand more, you want to get more related terms to nuclear fission and fusion in this example. How do you do that, right? So, how many of you know what key phrases are? Okay, so key phrases are essentially document tags that you may have come across in documents that are very informative about what that document means. So there are many key phrase algorithms. So an example of a big, so if I were to look at, what the hackathon is about, right? I might have key phrases that say hackathon, 1 week, developers, global, blah, 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 right? So these are informative phrases. The minute I say this, you actually get a good sense of what I'm talking about when I say OpenEd.ai hackathon, right? So these are key phrases. Now there are many ways of generating key phrases, but let's say you use any key phrase algorithm, right? You'll find tons online. So let's say I take the top K instructions, top K documents that I have found with my simple query, and I fire, I extract key phrases. Those will end up giving me terms that are very related to this domain of nuclear fission and fusion, right? So that's one way of augmenting. You could do similar things with articles in Wikipedia or other sources that you have, and I won't really go into details of everything else we've tried, and you can read the paper that I'll refer to for more details. But the point is, given this instruction, now you've got a slightly enriched semantic representation of what those instructions really were. And now potentially it will be more useful for this to actually be used for figuring out what the content so which content is talking about which instruction, right? Because the instruction also knows a lot more about the domain. And we then have, so this is what we do. We take each instruction, enrich it with some semantic vocabulary, and then take a matching algorithm that's actually, again, a vector-based representation of the document, which is relying on some of the features we talked about, and then does a prediction of which instruction is most closest to which course material, right? Which course material is talking about which instruction. And you might think, right, why don't you just train a classifier for each instruction, right? You have, how many classes do you have? You have n classes, you have document. Let's say you had labeled data, you would just train a classifier around that. You could, but it's still challenging because you will never have enough data for different learning instructions, because just to give you a sense of the number of learning instructions that you have, the learning standard that we actually work with, which was not CBSE, it was something called AKS, it has something like tens of thousands of instructions. Now, if you could get tens of thousands of instructions with adequate label data, sure, but we don't, right? That's a real world problem, but you still need to solve it, which is why we take it like a labeling task where we try to match the course instructions with this, with the course, with the learning documents, and try to associate them together. So how well does it really work, right? So we had some documents that we got from course teachers who had actually labeled these documents based on the course objectives. So they were subject matter experts who had actually labeled them. And we had, I think, 150 or 160 documents in math and somewhere around that number in science. I forget the exact number. And we found that our instruction level precision, which means just trying to match that exact instruction, right? Calculate average velocity based on velocity time graph or something, acceleration with velocity time graph, or instructions like this, was an accuracy of 80% on the content, right? For math, and for science it was about 70%. And we found that the way the learning standard is organized affects the accuracy. How the instructions are specified affects the accuracy, because the instructions could be imprecise, they could be vague, they could be talking about, they may not be very, very granular in themselves. The learning standard itself, right, given that we were relying very heavily on the fact that we know that there is a grade and there is a subject and there is a course and there is a topic. So that actually helps us in our matching algorithm. I didn't really go into details of all of that, but we rely heavily on that structure being present. Now, if you had a very flat structure, you lose a lot of structure, you lose a lot of that information. The organization of the learning standard in the curriculum also helps. If it's a flatter tree, it automatically drops, it causes the accuracy to drop. And this is again available as part of the same offering that I was referring to. See the papers that I have referred to here for more details on exactly how this works and what our experimentation methodology was like. Okay, so has anybody noticed a problem with this so far? So what would happen if I gave you a textbook? It would probably end up matching each instruction there, right? Because the textbook is going to cover everything. So that defeats the whole purpose of whatever we did so far, because if if they were lecture notes, if they were tutorial notes, it's good, right? Because they'll be related to some topic or the other. But if I gave a textbook, technically all instructions will match that textbook at some point in time, right? All of this for what then, right? So then we make improvements to this, right? What would be the most logical improvement? Let's analyze pieces of text, right? Let's break the text down into semantic topics that are related to each other and then link the concepts, right? That could be one way of doing that. And we do that, right? So here's an example just to motivate this slightly more, struck in slightly more better. So these are 2 pages from the NCERT textbook in class 10, I think, yeah. So one is from chapter 3. I don't know if you can read the text, but I'll read out some of the relevant parts. So the right hand side has chapter 3, the left hand side has chapter 5. So this is an example of a real instruction, right? It says, investigate the properties of a substance before, during, and after a chemical reaction to find the evidence of change. Now this particular section is talking about that, right? And that's good, so we know that. So if I'd given you the entire book for this, it's kind of pointless, right? But I want to be able to give you something like this. Now similarly, if you look at the other one, which is talking about use the periodic table to, use the periodic table to predict trends such as ionization energy, electronegativity, reactivity, oxidation number, blah, 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 right? So if you see the one on the right, it's actually talking about the reactivity series. And the one on the left is talking about the valency of atoms and the atomic size, right? Both of these are very related to this concept. Both of them are in different chapters. But now again, if I had given you just the entire book, I mean, it's pointless. I actually want to be able to give you this, right? Only then does it make sense. Right. Mm-hmm. No, so we're not looking at machine. So this wasn't tackled as a machine comprehension problem. This was tackled. I'll just tell you what we did, so, which is actually the next slide. So we trained vectors. We trained word vectors. So how many of you know what word2vec or similar models are like? Word vectors are like? Okay, so I'll just tell you what that is for people who may not have that background. So let's say you have, so there are many ways of generating representations, but a word vector is essentially just a representation of a word in some space, okay? And what is that space? So the way you would want to do it, so what would you want these word vectors to actually do? You want to have a semantic representation of these words, which captures some relationship about these words, okay? And what I mean by that is, let's say you have this big corpus of text, okay? And what I'm trying to do is, for every word, I want to understand what are its background words. So I could have a prediction model that says, given this word, I will try and predict what are the words that come around it most of the time. And then I could train a model that actually captures these relationships over billions of words and come up with some representation in vector space such that when I use them, I mean, those vectors have been learned by using these phenomena. And the interesting thing is, if the same word occurs in similar contexts, other words which are synonyms of it will occur in similar contexts, right? So when I were to use these vectors for, let's say, similarity, these vectors should have a closer cosine distance. The similarity score should be close, right? It should be high. So that's the intent behind word vectors. And we actually use word vectors for a feature representation, right? So it's a pretty simple thing. So you take text, you want to identify k-splits, where k is a hyperparameter. You say, I'm going to take my textbook, I'm going to take my lecture note, I'm going to figure out k-splits in the document. And you essentially just do that, right? You can treat it as this is just a dynamic programming problem where you are minimizing a cost function that is identifying boundaries such that the mean vector of that segment that you have potentially identified as a candidate is within a certain distance, or and the sentence that you're figuring out whether you which is identifying your chunk boundary is within a certain distance, right? So that's when you minimize that over the entire document, you're getting chunks that are semantically very related because the vectors are capturing semantics. And that's what we do. And to speed this up, in practice we found if you just use a greedy approach, it was fairly good, right? Now you could see that this is Not so you would think, does this really work well? It seems a pretty simple thing. It does actually work pretty well. One of the drawbacks again of this is that the splits aren't really guided by the topics that we have given, that we've already been given in the learning standard, right? We're doing the segmentation based on some topical cohesivity and then labeling the instructions with them. So you could think like if the instructions were very, very, very granular, something that was beyond what a paragraph or a paragraph or two would do, then it'll probably still give you like a 2 3 paragraphs worth of text, which is still okay. You don't really have to. We're not trying to solve a question answering task. If that becomes a question answering task where you say, well, this is the sentence that actually does what it's doing, or these are the collection of sentences that you're actually doing. We don't really need to do that, right? It's always helpful for the student to have some context around what the learning material is teaching, and that's good. So this is what we did next, and again we had like a sentence level F score on some test set that we got, and we found that our methods were also good baselines for other NLP tasks like document passage retrieval. So I think the web QA data set has been shared as part of the resources, right? So we actually used this as a baseline on the web QA data set. It was a good baseline. So it's not solving the task, but without doing anything, it was just a decent enough baseline that you could use, and you could obviously do improvements. There were obvious flaws from a question answering perspective that could have been done to improve this, but obviously that wasn't a task, but we were just seeing how that does for curiosity. And you can just see our paper for some more of these details. Um, yeah, so I think this hopefully summarizes what is. Go ahead. Yes. Yes. So I mean, what we did was a pretty trivial thing. We just added the vectors and renormalized them. The average vectors is what we were using as new, as a sentence vector, and even for the paragraph or the chunk boundary as new. Yeah, so I mean, yeah, so it was that DP cost function that we were optimizing. Yeah. So, yeah, so I think it's so instead of relying, so teachers today instead of relying on just their memory and experience have more data-driven, back evidence-driven insight to what how the students are doing and what they should be doing. Um, the feedback is more objective. Their ideas are, I mean, it's also scalable for every student instead of just having to manually choose which student to focus on first. If the teacher goes away mid-session, all of that is actually lost because the experience goes away. All that experience now persists because it is actually coming from a machine, and is now universally available. So this is, so I won't spend too much on this. This is just basically just showcasing what the Enlight Studio could do. Now let me quickly zip through the other use cases. Some of the stuff that we're looking at is early childhood learning. So, so one of the things that's so one of the things that's important in early childhood is vocabulary building, right? Um, so within and it's important, and it's so so people from privileged backgrounds or educated backgrounds over there over the first 3 years are exposed to 30 million more words than somebody who's not, and that has a huge effect on how people learn and study in future, because if their language skills aren't that great or if their ability to comprehend isn't really that great, and it's the early years where most of these neurons are actually generated, and if they are not really if they don't get that sort of stimulation at the right age, it actually affects them for the rest of their lives. So it's important to enable that right in the beginning, and we are using some of our work to create products that help students learn better. So there's a AR app that allows students to children to just move around and recognize objects, and it helps you learn more about that vocabulary. I mean, build their vocabulary by telling you more about what those instruments are or objects are in the real world. They also have a friendly monster that the child can play with, and it gives them recommended videos that they can watch. Um, there are some games, and it's obviously not dialogue. It's dialogue driven and not text driven because it's kids like less than 3 years old or 3 years old. So that's something we're doing. I just thought I'll put that there. It's not really something I want to spend too much time on. The last one of these is the cognitive career counseling, right? So remember we talked about K to 12. Now we talked about the early childhood. We talked about colleges a little bit. We want to also enable students to be equipped for the jobs and the careers ahead. So we're actually building a whole set of APIs and inside APIs, as we're calling them, to to support a wide variety of stakeholders in this whole exercise. You have employers, you have students, you have aggregators, you have job portals, you have certification agencies, you have training providers. So to be able to give them the right, we're building APIs that allow them all to interact with the working system and then get their needs fulfilled. So for example, it could help students or individuals identify the kind of job skills that there are in the market and what they should be catering for. Because you have connected with training providers and certification agencies, you can then relate that two together and give recommendations for trainings and certifications within your locality and things like that, because you have all of that data. Similarly, employers can then look out for candidates who are skilled or who are likely to graduate and are going to be going to be good matches for for the work that they do. It is also useful for training providers, because now training providers understand, well, these are the skills that are there in the market. These are the students that are coming in. I can see there's a big skill gap. So it makes sense for me to be putting out trainings that actually fulfill that gap. So this whole ecosystem would actually enable um, the what we're calling like a cognitive career counselor, because that's essentially what a career counselor does, right? You go to a career counselor and say, this is what I like to do. I don't know how to get there. What should I do? They will probably tell you, here's this is what your interests look like. These are the sort of things that you can become if you take this path. These are the sort of things you could do if you take this path. And we're trying to enable all of that in an automated system. So I'll come to the last bit, and I'll talk about personalized tutoring. So we talked about, like, the best experience potentially that we could have as a learner is to have some sort of cognitive teacher, right? Like a personal computer system that teaches you. So if you think about it at a very abstract level, what would that really mean, right? What would such a system really need? So one of the things that you should be able to do with the system is ask questions, obviously. You should be able to get answers for that system. The system by itself needs to be able to analyze what you have said. It needs to be able to process what you have said meaningfully for that course that you're looking at, not just from a conversation point of view, but from a content point of view as well. It needs to, okay, so and then it needs to be able to sustain a conversation dialogue, right? It can't be, I ask you a question, it gives an answer, or vice versa, and game over. It needs to be able to sustain a conversation. How do you sustain a conversation? What sort of a conversation would you have with the tutor? It could go any which way. You could be asking doubts. You could be assessed by a system. So the conversation agent, the tutoring system, actually needs to be able to support all of this for it to be a meaningful experience for students and learners, and not just a toy that they play with, right? So let's look at some problems, right? So let's say, so how does a tutoring system ask questions? It could be like somebody writes questions and gives it to them, but that's kind of, it's not going to scale. It's kind of pointless, because today I have a tutoring system for chemistry. Tomorrow I want one for machine learning. Like, what am I going to do, right? I can't be creating handcrafted questions for each of them for everybody. So that's one problem, right? How do you generate questions from text? You have a whole bunch of corpus. You have a whole bunch of corpora on learning resources. One of the simple problems is just generate meaningful questions that a tutoring system should use for tutoring, right? And that could be one of the questions which is, I think you think of trying to tackle in a hackathon, right? Because it's still a complicated task, but it has well-defined boundaries within which you could get certain accuracies and certain results that might be useful for such a system. But the other thing is also, it's not just as simple as generating questions. You need to be able to see what is a difficult question and what is an easy question, right? If I'm asking you what is X, what is X, what is Y, what is Z, in a series of conversations and saying, oh, I assessed you, it means nothing from an assessment point of view, from a personalized tutoring point of view. I need to be able to generate questions with varying skill level or difficulty. I don't even know how you would quantify that. What does that even mean? What is a difficult question? Is it difficulty ingrained, or is difficulty relative to the person who the question is being asked to? Probably both. But I think we would all agree there are certain difficult questions and there are certain simple questions. What does that really mean? That's something that the tutor should be able to figure out. Um, think about this a little bit more. So I'm asking you questions on a certain topic. You don't understand that topic. Let's say you did not do well on that topic. You gave me a bad answer. Now what? Right? I could give you the correct answer and that would be game over. But that's not what a teacher does, right? The teacher knows you probably messed up on this question because you did not understand something else previously. If you can't solve a quadratic equation because you don't understand what quadratic means, you first need to understand what quadratic means, right? So does the tutor, right? To be able to have a meaningful conversation with you for learning. So how do you potentially relate concepts that tell you what is a prerequisite for another? So without that, a conversation tutor will not be able to do anything. Can that be something that's also something that you guys could look at in a hackathon, for example? Let's let's move to analyzing. Right. So far we've been talking about what the system should know. Let's talk about what the system should be able to do. It should be able to assess what you've said. Is it correct? Is it partially correct? Is it incorrect? How would you do this in a manner that can scale across different domains, right? You could say, I will hand construct a big corpus and just feed it to my tutoring system to pick one of them, and I will have a model that just decides how to pick. Sure, that's a good first approach, but it will not work for anything that I give you next, right? Tomorrow I tell you that I want to have a tutoring system that can answer questions just for this particular chapter in chemistry, and it's game over, right? You can't do that unless you've thought that through. So a lot of this, if you think about it from a solutioning point of view, is about, well, what data do I really use, right? I don't have data for all of this. How do I get data that will say that this is the concept, these are the questions for it, or this is how difficult they are? You don't have that. But think about, can you use, at least for those of you who are from an NLP background, you might know of these tasks. But can you use other things people are doing? For example, textual entailment. Textual entailment is the problem of saying, given two sentences, does one entail the fact in the other automatically or not, right? So you try doing that automatically. So that's the textual entailment challenge. And you could think, I could potentially take the QA task as an entailment challenge. I could say, I have, let's say, my textbook, or I have an answer. I want to see if what the student said is entailed by what the text said, right? Maybe it is. This is also very related to your machine comprehension challenges, right? Because is that, can you answer that question from that from that text that I gave you? Now, it's a different formulation slightly, but it's related, right? And you could think about that as a problem statement. Then, of course, is the question of how do you sustain conversation and dialogue, right? It can't be I ask you a question and I'm done with, or it'll be kind of boring and it won't really work well. I also need to be able to present hint and guidance, maybe nudge you gently if you give me an incomplete answer, because not everything is right or wrong. You may have given me a partially correct answer. How do I generate hints? How do I give you guidance? How do I assess what your hints, how do I assess how you did on those hints? These are all open problems um, that are still open out there, right? I mean, the reason why we don't have a working personalized tutor in the world right now is because some aspect of learning is still missing in them. When a system gives you feedback, right, it should be constructive, it should be helpful. Ideally, it should be able to assess how you're feeling. It should not be, if you're looking frustrated, or if your responses, let's say you had a series of bad questions where you could not answer very well, right? The tutoring system should not be agnostic to that. It should not give you feedback that either disengages you or frustrates you, or suggests that you maybe I give up on this. Right? It should be constructive and helpful. How do you make that happen? How do you define what that is? How do you track all of that? So I think these are important questions that need to be addressed for personalized tutoring. And I think I am 10 minutes over my time, so I will end here. Thank you. And if there are any questions, maybe I can take that for 5 minutes before I hand over to Karan, who will walk you through some of the IBM Watson APIs that we have. You all have BlueMax access now. Most of you have BlueMax access now. So he will walk you through how you set that up. And we have also some, apart from these, we've also defined some problem statements which are slightly more compact. And I'll walk you through what those tasks are, and potentially, once Karan is done with this session, suggest what Watson APIs could be useful for those tasks.